Good evening, my YouTube viewers. It's Crystal here, and I wanted to do another code review. This is a code review for a Kaggle Playground Competition, Season 4, Episode 9. And what in this particular competition, what we're going to do is we're going to make predictions on used car prices. That's what we're going to do. And I used the ExtraTrees model, but the ExtraTrees model was not the only model that I used to try to solve this problem. I started out with linear regression, and then after linear regression I used TensorFlow linear regression, and then I used ExtraTrees. And then in addition to that, I wanted to try feature selection, but Kaggle will only let me make 5 submissions a day, so I couldn't do any feature selection today to see if I could improve my score with feature selection. So I'm just making a video on what I've got, and what I will do whenever I upload this video, I will give you a link to the Jupyter notebook. And I would have liked to have done the feature selection, but Kaggle is very restrictive, only let me make 5 submissions a day, and I made all my 5 submissions. So the first thing we do is the data set that we use, we got from the regression of used car prices. The best score, and the score on this one is 73751, and that was the best score, and that's why I'm using this Jupyter notebook and not the Jupyter notebook for linear regression and TensorFlow. So we look at the problem statement. The problem statement is predict on used car prices. And then after that, what we're going to do is we're going to import the libraries. So we're going to import NumPy as NP to create NumPy arrays and perform numerical computations. We're going to import pandas as PG to create data frames in series and process the data. We're going to import OS to go into the operating system and retrieve the CSV files. We're going to import scipy.stats to do the Kolmogorov.Smirnov test to see if the columns in the train and the test set are from the same distribution. We're going to import sklearn to provide machine learning functionality. We're going to import matplotlib.pyplot to visualize the data to make graphs. And then we're going to import sklearn to statistically visualize the data graphs. So now what we're going to do is we're going to use OS to actually locate the data sets. And this is from the operating system. And this is the code that we use to do that. We're going to read the data sets and convert them into data frames. But the first thing that we want to do is we want to make it so that the visualization isn't in scientific notation, because whenever I did this Jupyter notebook, it was in scientific notation. I didn't want that, so we just want it in quotes. And then so we take the 3 data sets that we have and we convert them into train, test, and submission. So you can see train, you've got 13 columns of train. We check the info. You can see a few integers, but most of them were object columns. Going to check to see if we've got any null values, and we've got quite a few null values. So what we're going to do is we're going to drop all the null values. we're going to drop all the null values and we're going to check for null values again, and we've got 0 null values again. We check for the shape. You see that we still got 13 columns, but we have less rows than we had before. And on the test is the same as the train, except for the fact that it doesn't have a price column. We check for null values, and then we check submission. This is the format that Kaggle wants to see when the predictions are submitted to them for scoring. So now what we're going to do is we're going to import the missing values from the test file. And so all of the missing values are in object columns. And since they're all in object columns, I only needed to impute for object columns. So for call and test.fill in a call colon not reported in place equals true. And then we check for null values again, and you see we don't have any null values. I would like to say that the way that null values are imputed is going to be done differently now, because I got a warning and in the warning told to impute the values this way. So that's something to keep in mind. And so I would just like to make a point about the large language models. When you're looking something up on a large language model, there's a possibility that you could be given deprecated code. So that's another problem that's going to need to be addressed in the future. So large language models, they give you code, but there's no guarantee that the code works. There's no guarantee that the code is the most recent code available. So now what we're going to do is we're going to check to see if the columns from train and test are from the same distribution, and we're going to perform the Kolmogorov Smirnov test to do that. And we check the train call against the test call, and it looks like if PV is less than 0.05, you add that column to the to-drop array. Well, you can see here that most of the columns are not in the same distribution. You've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 columns that are not in the same distribution. So that means this is a pretty difficult data set to work with, because the columns are not in the same distribution. But I decided in this instance just to drop the ID column, because you don't need the ID column. The reason why is because Pandas automatically indexes every row, so you don't need it. We check the shape, and so in train you've got 12 columns of data, and in test you've got 11 columns of data. Okay, so now what we're going to do is we're going to encode the features, and then you have to make sure that when you handle unknown data, it has to say use encoded value, and the unknown value is -1. So for call and train, if train call D type equals object, train call equals inc fit transform, train call dot values dot reshape -1 comp 1. Test call equals inc dot transform, test call dot values dot reshape -1 1. So basically on the train column you fit and transform the data, and on the test column you transform the data. But if there are any, you have to use handle unknown equals use encoded value to be able to handle unknown values. If you don't do that, then the program will crash when it encounters an unknown value. So now what we're going to do is we're going to analyze our target. So target equals train pop price. So that means you're just taking the target out of the data frame. And now what we're going to do is we're going to describe the target. You can see the count, the mean, the standard deviation. The minimum value is 2,000. What you've got for 25%, 50%, 75%, and you've got the maximum value is 2,954,083. So that's very large variation. So now what we're going to do is we're going to create a disk plot on the target, and KDE, that's kernel distribution estimate, kernel density estimate. And we're going to have 20 bins in place. So this is what the histogram looks like with 20 bins in place. We're going to, that was a disk plot. This is a histogram, and the histogram doesn't have a KDE equals true. I could have tried it. I could have tried KDE to see if it was true, but I didn't. But this is what the histogram looks like in Seaborn. So you can see you've got your disk plot and you've got your histogram. So we're going to create a heat map, and that's going to be done in Seaborn as well. So core equals train.core, sns.heatmapcore. So you can see the heat map, and this will tell you the features that have a high correlation. So you can see that none of the features are highly correlated because they all have a dark coloring. And since none of them are highly correlated, we're not going to drop any of the features with a high correlation. But even when you drop the features, when you utilize feature selection, you always take the risk that you're going to lose accuracy. And that's another point that needs to be brought up. So now we're going to define the dependent and independent variables. Y is your target, X is your train, and X test is your test. So we're going to use train test split to split the data set into training and validation sets. And the test size is going to be 0.1. We're going to shuffle it, and the random state equals 42. And the random state is just to keep it, to give you the same output every time you do it. Now we're going to define model, which I probably should have put in there, define model, but somehow or other it didn't get put in there, or it accidentally got deleted. Model equals ExtraTrees regressor. I gave it a max depth of 5, a random state of 42, and you fit the X train, Y train, and then we check the score. The score was 0.12. If I had a max depth of 0, it would have been 99%. Now we check for YPRED. YPRED equals model.predict xval. YPRED, if YPRED is less than 0, then it's going to be 2,000. And the reason why I put that in there is because 2,000 was the lowest value that was in the target. Now we're going to create a data frame, and this data frame that we're going to create is going to give you your actual values and your predicted values, and you can compare the actual values to predicted values and see how they fare. So we're going to check our root mean squared error. This is another thing that we have, because the newest version of sklearn has a root mean squared error function, but this Jupyter notebook is not operating on the newest version, and since it's not operating on the newest version, I had to use mean squared error. And I think that if you said squared equals true, if you set it up for squared equals true, squared equals false, then what would happen is it would automatically square it. But in the newest version of sklearn for the mean squared error, they've taken that parameter out because they just put in a new function of root mean squared error. And so since it's not using root mean squared error in the version of sklearn that this Jupyter Notebook has, I just said RMSE equals MSE to the power of 0.5, and that is your root mean squared error. So you've got a root mean squared error of 92,266. And now what we're going to do is we're going to visualize the data using Matplotlib, and you can see here that the actual values don't align very well with the prediction line. So that's a problem that we're having to work with. And now we're checking our features, checking the feature importances, so you can see which features are more important than any of the others. So the features that have the highest importance are mileage, engine, model year, and accident. And the other features are very low. And what I had decided to do under feature selection was I just decided to use the highest features. But I can't do that today because Kaggle won't allow me to submit any more work. So now we're going to predict on the test set. So prediction equals model.predict x test. And then prediction, if the prediction is less than 0, it's 2000, and then you get your prediction. And now we're going to prepare our submission. Submission price equals prediction. Submission.toCSV is bracket submission.csv index equals false. Submission equals pd.readCSV, submission CSV, and this is your submission. So this is the work that we submitted to Kaggle after we saved the Jupyter Notebook. And when we saved the Jupyter Notebook, the RMSE that we got was 73751. So that was the highest RMSE that I was able to get. So that's it for this particular code review. I'm going to go ahead and conclude because I talked to you about the code, everything I did in the code. And if you like my video, please like and subscribe. And thank you for watching my video. I look forward to making more videos for you in the future.